Hello everyone, this is the laboratory number 2, electric circuit and Kirchhoff's laws. The objective of this lab is that to determine the total resistance value by reading the multimeter. We will use the multimeter in this lab and to apply the Kirchhoff's laws for several circuit diagrams. So the main part of this lab is Kirchhoff's laws. Here I list the theory and equations we were going to use in this experiment. So first of all, which is the Ohm's law. Ohm's law you have learned maybe in high school, but here we just review it because we will do several practice in this lab based on the Ohm's law at the beginning. Okay, then Ohm's law states that the relationship of voltage, current, and resistance, and we give you this formula, V equals to I times R. Then 1A, the resistors connected in series share the same current, which V equals to I times R total. So we give the formula about the resistance formula in series circuit. R total equals to R1 plus R2 plus go to Rn. Then it comes to 1B. The resistor connected in parallel share the same voltage. And give the formula here. I is current equals to U voltage divided by R total. But the R total here is in the parallel circuit. Then we use the different formula for the R total in the parallel circuit, which is given here. 1 over R total equals 1 over R1, 1 over plus 1 over R2 plus go to the plus go to the 1 over Rn. So here is the Ohm's law. Let's come to the Kirchhoff's law. First of all, I just explain what is the Kirchhoff's laws. So Kirchhoff's laws is separated into two parts. One part we call voltage law, and then the second one is the current law. Voltage law, current law. So let's see what is the voltage law. The Kirchhoff's voltage law states that the summation of the voltage of the loop must be 0. So give you this one, summation V loop equals to 0. Then this is for 2A, Kirchhoff's voltage law. Then comes to 2B, Kirchhoff's current laws. Kirchhoff's current law states that the current summation entering the given point must be equals to the summation of all currents leaving the same point. So, which is summation current I in equals summation current I out. So here just tell you the definition of the Kirchhoff's law, okay, Kirchhoff voltage law and Kirchhoff current law. Then come to here, I will explain you one by one. So first of all, Kirchhoff voltage law here, okay. So what is Kirchhoff's voltage law? We must have a loop first, because here summation V loop equals to 0. So we have a loop first. Let's define a loop first, okay? So imagine we have a loop here, and here is resistors. In this circuit, okay, in this loop, we have three resistors. I give them the name R1, R2, and R3. In this loop, we define a direction. we see, okay, this is the direction of in this loop. Then we use the multimeter parallel on it to see the voltage on each resistors. Okay, then I change now color, come to the red. So because we define the loop, the direction here, right? In this direction, so this is direction plus, minus, plus, minus, plus, and minus. This is for the wire plus a net positive wire and negative wire for all of the voltage meter. Then after that, when we read the voltage meter, it will get VR1 plus VR2 plus VR3 equals to 0, which is fulfilled the V summation of V loop equals to 0. This is KVL. Then we come to KCL, Kirchhoff's current law. In KCL, you should have a point. So in KVL, we must have a loop. In KCL, we should have a point, a given point. Then we just define, okay. So two current comes in. One current goes out. Then we define, okay, this one called I1, this one called I2, this one called I3. Then imagine we have the ampermeter. Then I put the ampermeter here. Here's the ampermeter. Ampermeter here. Another ampermeter here. Also, we give the direction we give already. So we come to put here. This is plus, minus, plus, minus, plus, and minus, because we define direction, right? Then, according to this, we will keep the formula I1 plus I2, which these two equals to I in, right? Flow into the given point equals to I3. I3, which is I out. So that's why we have the formula there. Summation I in equals to summation I out. This is the Kirchhoff current law. So we have 3 parts. Now is part 1. Part 1 is that record the resistance value by using multimeter and reading the color code. So it may be the first time for you to hear the color code. Then I'll tell you how to read the color code. We have a picture here, and in this photo, it shows a resistor, a real resistor, which looks like this one. 1, 2, 3, and the last one, number 4. So we give them the name A, first digit. For example, in this picture, it is green. Okay, first it is called A. The black one called B. B is the second digit. Then go to the red one, C, we call multiplier. D, we call tolerance. For A, B, and C, black means 0. Brown means 1. Then we write all of the color. Then the number for the color represent. Then for D has another group of the meaning. Gold means 5%, silver means 10%, and now no color means 20%. And we have this formula. AB is a number times 10 power to C plus minus D percent, and then give a unit, the resistance unit omega. Okay, so we use this photo, this graph, to as an example. First one, the first digit, A, it is green. So we go to find green here. Green is 5. Then we go to the black number, black color. Then the number is 0. Okay, black means 0. Then go to the red. Red is C. So AB we have already times 10. Then the multiplier is red. Red means 2. Okay, then we have an error. D is tolerance, which is golden. Then the gold means 5%. So we write here 5%. Then we give a unit omega. So finally, it is 50 times 10 power to 2 plus minus 5% omega. So this is the resistance of this resistor. Now let's have a quick look about the report that I give it to you, and how many sections are there in this document. So the first of all, I have mentioned already in the previous video the theory part of this lab. Okay, come to the experiment part. As what I said just now, there are 3 parts. Part 1, record the resistance. And I have explained it already, and tell you how to read a resistor, the resistance. Okay, come to here, you have a table. So I'll show you a picture in the experimental video that we have totally 5 resistors from R1 to R5, and you need to go to read it. Read the color code, and then read the color code, and then you will get a reading resistance omega. After that, measure the resistance. I will do it for you, but you need to go to read on the multimeter. Okay, this is the first part. Now we come to the second part. Part 2, record the resistor circuit using multimeter. Then here, part 2, and number 2. This is a series circuit. Then we have R1, R2, R3, and we need to measure R12, R23, and R123. We will measure it by multimeter, and at the same time, we need to use what you read from the color code and calculate R total using this equation. So one is from you calculate, you read, and then calculate, and another one is you read from the multimeter. We will compare these 2 results. So come to, now it's number 3. Use the same method, but now we change to parallel circuit. Then we also have R1, R2, R3. we want to know what is R12. And we will measure R12. Then also you need to calculate R12 using this formula. Then we compare the two results. Number 4, this is a parallel and series combination circuit. R2, R3, they are in a parallel circuit. R1 and the group R2, R3, they are series circuit. Okay, so same time we list this formula here. Also, we need to measure it. R123, R1, R23. Then you compare with your calculation. From picture 2, 3, and 4. Together, you have a table here. Then fill in your result inside this table. Next part comes to part 3, which is the most difficult part in this lab, and also which is the main part of this lab. Kirchhoff's law. To measure the voltage and current using digital multimeter. Voltage, current, and using digital multimeter, then analyze the experimental result using Kirchhoff's law. You get a circuit like this. Then we'll set up this circuit, and then there's a table here. We will measure current, voltage from AC, from CD, from DA. This is for loop 1. Do you remember what is the Kirchhoff's voltage law? We need to find the loop first, right? So now we have 2 loops here, which is loop 1, ACD, loop 2, CBD. Right, so, and we will measure the voltage and current in this circuit. Now it is the report part. But I put all of them, the theory part and the introduction part, and come to now is the report part. I put all of them in one document, in one file, PDF file. I hope that all of you can print it out. But when you give the report to me, when you send the report to me, what I need is only the laboratory report number 2. Okay, so I only read this part as your report and give you score. So here I just summarize and know any circuit graph, anything that you just have to give to me the table, your result, your calculation, your discussion, and so on. Okay, so here is part 1 as what I showed just now. Part 1, you have a table here and reading the color code and read the multimeter I showed you. Then part 2, also a table. Part 2, which is the 3 different kind of circuit, right? 3 different kind of graph, series, parallel, and combined. After that is your calculation. I showed you the formula already, right? Then you use that formula to calculate in the series circuit, R1 to R13, R1 to 3 calculation. For parallel circuit, 1, 2, 3. For the combination circuit, R1, 2, R1, 2, 3. When you finish your calculation, put your result, go back into this table. Okay, this is table part 2, table 2. What I write it here, for example, parallel R12 calculation measurement, where I give the sign here, it means no, you don't need to fill in, okay? You just fill in the table that with the empty blank. It means no, you don't need to do it, okay? And here, no, no. Let's go to next part 3. In part 3, also you need to fill in all of them. This table you fill in. This is from measurement, and you just read by reading the multimeter, okay? After that is your calculation. You have measurement from multimeter, then you need to use the series, use the Kirchhoff's law measurement to calculate here loop. 3.2 is about this formula, and you show the current calculation at position A and B, okay? Then calculate using the Kirchhoff's law, I2, I3. At the same time, we'll calculate I using Ohm's law, okay? And summary result, 2 points. Then after that, finally, you have a quiz. 2 very easy questions. Then you answer this quiz in here, okay? You have 2 quiz. After that, that's all of this.